So, first of all, thank you folks for being here and spending time on this. Today, myself, Rahul, and Arun will take you through our journey of using Airflow to power a LinkedIn scale continuous deployment platform. If some of you remember us, we were here last year also. Last year, we talked a lot about what is the continuous deployment platform, why did we build up from ground up, and how did we use Airflow and why did we use Airflow. Today, we are going to take a step further. We are going to talk about all the features, all the enhancements that we built around Airflow to meet LinkedIn scale, meet LinkedIn engineering requirements, and integrate with the existing LinkedIn ecosystem. The end goal after this talk, I hope, is you all take an idea from us of how you can leverage Airflow to build an enterprise scale orchestration platform. Next step. A little bit about us. I am Rahul. I'm a senior staff at LinkedIn. I have been at LinkedIn for about 4 years. This is my second series of speaker and Airflow. Other than work, I do have hobbies. One of them is pickleball. I used to play tennis. I recently switched to pickleball, and my knees are much, much happier. My reflexes are much, much faster. And the second thing I enjoy is spending time with my kids, especially playing cricket. My younger one is crazy about it, and meeting his energy needs and levels is one of the most demanding projects I have. Arun?
Hello, everyone. I'm Arun. I'm with LinkedIn for almost 6 years now. This is my first time presenting in Airflow conference, but being a Airflow lover, I tune into the Airflow Tech Talks and understand how folks are leveraging Airflow to solve their complex problem. When I'm not working, I love to stay close to nature, so I go for small hikes. I used to play cricket, but it's really difficult to find a team of 10 people, so I switched to table tennis now. It's easy to find one opponent quickly. With that, pass it on to Rahul.
So we all know about LinkedIn. What I'm going to talk about is the scale that our platform has today. LinkedIn has about 10,000 engineers, and each of them is using this platform on a daily basis to do some kind of deployment via this platform. Today, LinkedIn has about 6,000 services. This includes all the online services, offline services like the Flink, internal Airflow use cases, ML pipelines, and so on. It also has a lot of complex stateful systems. Our platform today has about 5,000 DAGs. On a daily basis, we run about 100K tasks. The most complex pipeline that we have is for an internal database application, which has about 800 tasks. And that is one of the most challenging pipeline that we have in our Airflow cluster. We do run our platform on multiple data centers to achieve redundancy, high availability, and scalability. Let's talk a minute about the platform vision and why it was even built. Before this platform, LinkedIn had a problem where every different use case had their own deployment platform. Like an offline system will have their deployment platform, an online system will have their own deployment platform, ML models will have their own deployment platform. We came up with a vision of having a unified deployment platform. Any team, any service, online, offline, or ML jobs deploys to this one single platform. Why does it help? First of all, it reduces user toil. Engineers no longer need to learn multiple deployment systems. It helps increasing their own developer productivity. It also enforces best practices. LinkedIn as a company can now standardize the policies like, hey, safe ramping, governance, everything like that can be enforced on one single platform. Last but not the least, touchless deployment. This was one of the most important vision that we had for our company. That is, as soon as a user merges his PR, version is created, platform takes over and ensures that the deployment is done across multiple fabrics without human involved. The goal was not to remove humans from the loop, but it wanted to make sure that there is consistency and same policies are applied across different pipelines in the environment, thus improving user productivity. Next. How did we achieve this? This is our platform architecture. We built up into multiple layers, starting up from the user interface, where UI is where all the engineers, the 10,000 engineers, interact with this platform. UI is where they can trigger deployments, view their pipelines and progress, and also do all of the things. Next up is the gateway layer, which is the deployment gateway service. That is the layer which does authentication and the routing, ensures the right users are able to interact with the right pipelines. Next up is the orchestration layer. We run Airflow cluster in different fabrics, helps us achieve availability, redundancy, and scalability. Gateway service is able to route the right pipeline to the right Airflow cluster. Bottom is the execution and the policy layer. Most of our tasks run as Kubernetes pod operator. They run in the K8s cluster you see. These tasks are short-lived tasks and run to completion. These tasks talk to the policy engine, and policy engine is the one which determines is it safe to move forward with the task or not. It is important for a company like LinkedIn to have the right policies in place to prevent deployments happening during non-business hours, to prevent deployments happening during moratorium, or if there's a big incident happening, we don't want to roll out new changes. We also have policies which prevent bad versions from getting rolled out, experimental MPs not getting deployed to production, and even library dependencies. Bad library dependency versions are not allowed to be deployed. All those stick in the policy engine. At the bottom is the most important layer, observability layer. All the tasks that run in the Kubernetes cluster talk to two things. One is Kusto and the deployment history. One is for structured logging, another one is for unstructured logging. Together with the deployment history and the gateway service, the UI is able to give a full picture of what's going on in your Airflow cluster to the users. Now, Arun will go into more details about all the features that we have built on top of Airflow that we have been using.
Thank you, Rahul, for setting up the context and talking about the various components. Now let's zoom into our Airflow world. So we are running Airflow in the control plane. From there, we can securely access all of our data centers and LinkedIn on its own data centers. We are not on cloud yet. When a deployment request comes in, our Kubernetes pod operator tap it into the K8s API server in the given cluster and spin up a short-lived pod over there. The pod do its due diligence, talk to the downstream to do the deployment, and run to completion. We lean heavily on Airflow hooks and callbacks. We are using pre-execute to update the pipeline status, as well as executing policy to ensure that we are executing the right action. No action can execute until policies say you are good to go. We are using post-execute hooks to ensure that we shut down cleanly, update the pipeline status, as well as persist the XCOM value, the result of the action execution. We handle sick terms gracefully. Sometimes we exit cleanly or retry when it makes sense for us. DAG callbacks are being used to send notification to the users about the current state. Also, it helps conclude the current state of the pipeline. From all these components, Airflow components along, as well as the pods, logs will flow into the custos, from where the service owner can query, correlate, and build dashboard as required. So now, as you are aware of about Airflow components, let's touch base on our action ecosystem. What are actions? Action is the smallest unit of work that we run in our platform. They are containers which we build during build time and execute as an Airflow task at runtime. Why actions? Using a container make our action language agnostic, so our partners can author action in technology they know, and all those PK language debates during stand-ups are avoided. We provide opinionated template and a standard image along with action so that our partners can focus on the business logic while we ensure standard execution, security, and observability across the services. Actions are reusable and they integrate well with our platform. For example, our validation team author an action to validate deployments at a pre-deploy stage and integrate the same with our platform very quickly. You can think of action, we write it once, containerize always, and use everywhere. Now let's go through a journey how a deployment goes end-to-end in a platform. A user comes into our UI and trigger a deployment. The request reach to our Airflow, and Airflow start executing our action in order one by one, like canary, validate, deploy, and so on. While action is getting executed, downstream scheduler is being called, generally a post request to do the job, and action keep polling the downstream until it's finished. Action passing its result back to the orchestrator, and orchestrator makes sure that those results and data is available for the next action to execute, so that every action has everything it needs to start. From the action authoring side, as we mentioned, we provide a library of templates. Our action author choose one of the template and add their business logic along with it. At post-merge step, we build a container image and push it onto the Artifactory. At runtime, Airflow download these images on the pod and run it to the completion. At LinkedIn scale, action rollout is as critical as action itself. The impact is twofold. If a bad action version got rolled out, it will impact a lot of deployment in LinkedIn, can easily cause incident. So safety is the key. On top of that, we really want our partners to roll out their action quickly. So speed matter for us. Last year, what we did is we try leveraging Airflow variable to store the action version, but it failed badly for us for a couple of reasons. One, this spiked the load on Airflow DB, which show performance degradation at other stages. Second, variables need to be updated in all Airflow cluster. So this poses a risk of version drift for us. And of course, it's adding human toil for our engineers. Third, there is no way to save or ramp the action version with the Airflow variables. Once a variable is updated, it's applied globally immediately. To solve this problem, we decouple action version rollout from Airflow ecosystem and start leveraging our AB experimental platform to roll out the action version. This allows us to ramp action version gradually and safely in all our clusters while not impacting our Airflow cluster, and rollbacks are pretty quick in case we see any failure. Release train. So release train is important to increase the rollout velocity. So when you are in a business of deployment, we really want deployment to go as fast as possible, but we really want to ensure safety along the way. In our DAG, we treat a sequence of tasks like canary, validate, and promote as one atomic unit. We call this as task, and in a given DAG, there can be multiple task groups for different environments. It's crucial for us that only one version of service is executed in a given task group at a given time, because we must canary a version before even we consider it for promote. Second, if multiple versions are there in the canary stage, there is a risk of race condition, and we are also risking promoting a bad version. To solve this problem and to ensure this exclusivity, we are using distributed locks, which ensure that only one version of the service is running at a given time when a given DAG is executing. We are also using max DAG run for each DAG configuration to make sure that no matter how many triggers are coming from the user, we are running limited instances of that DAG in a production. At scale, not every change should go through fully automation. Sometimes we need pair of human eyes to ensure safety. And this is critical in scenario where there are regulations which require human sign-off for auditability and traceability. And also when a change is costly, which gonna impact the revenue stream as well as our LinkedIn user experience. So how we achieve this? So we allow our engineers to configure their DAG pipeline in a way that they can introduce a pause and validate step in their configuration. And a workflow got stopped at that step, and some human can come in, can review the change, can approve it, or modify it to modify the outcome from this result. So this really make our execution as safe as possible while we make sure that we still achieve the velocity. Next, manual overrides. Manual overrides empower our engineers to manually bypass a step and or make rerun a step when required to continue our workflow execution. This is critical because in some time our downstream systems are sending false positive to us. So it's safe for us to mark that step as success and move further with our workflow. Second, in some during some incident, if there are policy which stop you to deploy to the next step, it's critical to provide the levers to our users so that they can pass in those policy override and continue to the deployment. Think of a scenario when there is an incident created and there is a global moratorium in LinkedIn, and somebody try to roll out a fix that's going to fix that incident. So our platform should be flexible enough to let those changes pass in, and these overrides are very helpful in those scenarios. We are achieving this by leveraging Airflow rerun and Airflow mark step offerings. Next, as we are onboarding more and more use cases on our platform, we start seeing there is some strain on our Airflow cluster. So what we did, we break up our Airflow infrastructure to spin up a list of a couple of Airflow clusters for us. So, and we are leveraging our gateway layer to route the traffic to the respective cluster based on our configuration. So this really helps us multiple ways. One, it helps us to distribute the load to multiple clusters instead of one. This helps us to provide high availability. In case one cluster goes down, we can easily route the traffic to the next available cluster with a small config change. And third, it provides isolation. For critical and some noisy workflow, we can isolate them to a single Airflow cluster. Along with that, each Airflow cluster can scale independently. This helps us with the right sizing capacity and cost optimization. Next. We talk a lot about pipeline execution. Now let's touch on how pipeline ingestion workflow work in our platform. Next. So one of the problems that we have seen is engineers use which is the source of heavy toil for our team as well as for our engineer is the wrong configuration. And because the workflow configurations are very complex and error prone. So we really want to handle this by introducing low code, no code workflow in our new platform. So how we do this? We provide a way where user can declaratively provide the intent of their deployment in a YAML workflow, and we store that information along with the product repo. So this helps us with the auditability as well as tracing the changes. We are also exposing a CLI to our engineers, and we have planned to move it to a UI in future, where we get the intent from the user as an input parameter in the CLI, and we build this YAML file for them at the backend. So they don't even need to go and touch any YAML file along the way. So once we have this intent configured from the user, in a post-merge job, what we are doing is we are converting this YAML to a DAG code, which got posted to Airflow as well as to our gateway layer. So our engineers don't need to worry about any DAG code execution. While we provide a way for our engineers to author the workflow smoothly, we really want to ensure that those workflow changes are good. And also, if we want to enforce some policies, some guidelines, like a couple of configurations are mandatory in their workflow, which engineers tend to skip. For example, deployment has to happen in a given order. Engineer must configure some Slack notification channel or team email address so that we can send appropriate notification when required. So to enforce all this policy, we integrate our platform with the Confetti, which is a validation platform in LinkedIn. So how this help us is, this help us to enforce those governance and policy guidelines. Along with that, it ensures that the workflow that user is configuring is adhering to the schema that we provide to the engineers, so that we can save us on the costly errors at the end. By shifting this validation to the left, we catch issue before even control reach to Airflow and saving a lot of cost and engineering effort in the deployment errors. With that, I'll pass it on to Rahul to talk about a couple of more features.
So to extend on that, we have something called as pipeline versioning. Just to let you know, we are not on 3.0 yet, and we had to build it on ourselves. So why is pipeline versioning important in our case? Arun talked about the use case that we have where users go and update no-code, low-code workflows. These are YAML files. and users can update at any time. And what happens when users update that and your pipeline is running? Currently, pre 3.0, the pipeline definition will update it. This causes inconsistent behavior as to what pipeline version was actually executed. Also, if you had to debug, going past and debug things, it's very confusing as to know what was the version that was running at time. So what we have done is something called as deferred updates. That means if your pipeline is running, we don't let the pipeline version be updated. Or if your pipeline is getting updated, don't allow a pipeline to be run. We have achieved this using the previous features that we talked about for release train, which was distributed locking. The same locking mechanism we have used to ensure that there is consistency, and if a pipeline which is in progress, no new versions will be updated during that time. How did we also achieve this was by using the callbacks, where once the pipeline finishes, the callback checks, hey, if there is any deferred update, if the answer is yes, let's update it, and then only allow a new pipeline run to even happen. Next. Another thing is better messaging. This is one of the most underrated feature for a deployment platform that was needed. We talked about how we have democratized action framework. That means anyone in LinkedIn can write an action, which is aka a Python task. Now that's great, we democratized that. But the side effect of that is, now there is no consistent behavior of what error messages or the messages that the task sends out, we can show it to the user. To achieve consistent behavior, what we have done is we have stronger contracts that we have with our action authors. That coupled up with our observability layer and the UI layer, we ensure the right messages land up on the UI page. The few contracts that we have is when the action runs in the pre-execute state, it should inform the users what the action is going to do and what is the expected outcomes. That's what you see on the slide, on the message on the bottom, where EKG is our internal validation tool. It takes about 40 minutes to run. It says, hey, we started this, it should end at this time, these are the expected messages. And if the action fails, as a part of post-execute, you would see something message at the top, which says, hey, your deployment failed for this reason, and these are the next steps that you should do. This is very important from an on-call perspective, because if users are not aware of what's happening, first thing they will do is ping our on-call. Having better messaging, user-friendly messaging, and actionable messages has helped reduce overall on-call toil and has helped improve the overall user experience. Dynamic DAGs. So we talked about few things, like as a deployment platform, one of our goal is touchless deployments. Another goal is site reliability. We achieve site reliability in a touchless fashion by enforcing deployments from less risky to the highest risky platform, fabrics. And in between, we do a lot of validations in between. So this does slow down deployments. But in scenarios of rollbacks, where someone wants to roll back a last known good version, or someone wants to roll out a hot fix on the most risky target, going in sequence is slow. And even though several minutes can impact the resolution of the incident. And we also use Kubernetes pod operator. That means every time we have to evaluate if the step needs to be run, the pod starts up, decides it doesn't need to execute the task, goes back. Those few seconds start to add up in case of pipelines which are very large, and they specifically want to target the last step in the pipeline. So what we did was we are using something called as dynamic DAGs, aka the fast paths, in case someone wants to roll back or do a targeted deployment. Now, we achieve that by using dynamic DAG, where the user specifies what targets to apply, and we just run that DAG. We achieve this, but the problem is now a user has to interact with two pipelines. One is a standard pipeline, which is the normal deployment, and one when he needs to do a fast deployment. That's not a good user experience. Again, our modular architecture helped us, where what we have is the UI layer, the gateway service, right? When the user says, hey, I want to do a fast rollback, UI and the gateway service interact together and decide it's time to run the fast path. But the user doesn't need to worry about this, and UI and the gateway service interact well to show a unified pipeline that has executed the deployment. As a result, the user experience is not impacted, and the user gets the fast path deployments that he always wanted. Next step. Overall, to achieve the LinkedIn scale, we have done few things. We already talked about horizontal scaling. One thing that we learned was Airflow is very database intensive. And earlier, our MySQL instance for Airflow was running on a host which was also running other MySQL instances. As a result, Airflow's MySQL was starving on resources, and eventually we moved to a dedicated host. The graphs at the bottom show the results of the time Airflow spent on the critical section just dropped as soon as it didn't have to fight for the resources. So a dedicated host for our MySQL also helped us a lot. Second thing that we are doing is Kubernetes executors. All our tasks, most of them, run as Kubernetes pod operators. Another thing that we did was updating the kubelet configuration. By default, about 64 pods can run on a node. We were able to increase it to 100. The reason being, most of the actions are not resource intensive. They are lightweight tasks, not doing CPU intensive operations. So we have limited the CPU and memory to the minimum that the action should run with. With that, with a less number of nodes, we can increase more number of pods that can run. We were running an older version of Airflow, so we also ran into issues where there was lack of retry capabilities whenever the interaction with MySQL failed. We had to add patches on top of it to get resiliency out. What is one thing that we dread about, but we learn a lot from it, and that's incidents. So we'll talk about one interesting use case that we had about an incident that we had, because that's a good learning curve for us. So during a specific day, what we started seeing was some of our pipelines started to fail. When we debugged it, why it's failing, the result was the pods were scaling, but the pods were failing. We debugged why the pods are failing. The pods were getting sick term. We looked deeper. Why is it getting a sick term? Because one of the scheduler was sending a sick term. We run our Airflow in an HA mode. So we have two schedulers running side by side. And the question was, why would a scheduler send a sick term when the task was running? What we observed was, since we are running in HA mode, the peer scheduler thought my peer is dead. Why would it do that? Airflow periodically scheduler runs a loop where it checks if there are orphan pods. And if it identifies orphan pods, as a good citizen, it goes and tries to inherit it. And the way it does that is by updating the pod metadata and says, hey, I own you now. When it does that, Kubernetes was sending an event called as deleted pod event. The other scheduler, which was not dead, received that event. And we had another configuration where if the pod is deleted, go and clean it up. So the other scheduler, being a good citizen, would go and delete that pod. And that's where the race condition happened and our pods were getting deleted. Now, why would the scheduler not send the heartbeat? Because that's how the other scheduler detects that, hey, the other scheduler is dead. The reason was the first slide that we had about the scale, where one of the DAG was the most complex, had 800 tasks. Processing it was taking more time, and as a result, the scheduler was not able to send the heartbeat. So two learnings from this. One is improve your DAG structure so that the processing time is as small as possible. And second thing is, don't be on that old Airflow version, because the latest Airflow versions have actually fixed that issue, where instead of sending a deleted, you also get an adopted event, which is a much better way to handle things. Looking ahead, what's for next year? We are going to scale up to 15K DAGs. Reason being, more and more use cases are being onboarded onto this LCD platform that we have at LinkedIn. We are looking forward to upgrade to the latest Airflow version. That's one of the main things that we have learned from past incidents. Hardware efficiency is the next goal that we have, where we want to make sure that the Airflow cluster can handle more and more DAGs and go forward from there. And with that, we'll wrap up our presentation and open for questions.